Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 1 paper from summer 2022. This paper is worth 120 marks in total, and this is the fourth video of 6. It will focus on questions 15 to 19, which account for 22 of these marks. Eduqas Component 1 papers are non-calculator, so a calculator should not be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 15. Rearrange this formula to make n the subject. So we have t equals 5 add 3n. When we're rearranging, we're changing the subject. So instead of it being t equals, we want our final answer to be n equals. N is the subject. So we're going to do inverse operations like we would do when we're solving equations, but we're not going to get a numerical answer. We're going to get another formula at the end. So the first thing I'm going to do is I'm going to isolate the n term. So I'm going to isolate 3n so that I can end up with n on its own on one side of the equation. So the first thing I'm going to do is eliminate the 5. This is a positive 5. I know it's a positive 5 because there's no negative sign in front of it. So to eliminate positive 5, I need to subtract 5 from both sides. So when I subtract 5 from the left-hand side, I've already got t there, but then I take away 5 from it. When I subtract 5 from the right-hand side, it cancels out the positive 5 and leaves me with 3n. So now looking at this, I've got 3n, but I want n. So what I'm going to do, guys, is I need to eliminate the 3 in front of the n. 3n means 3 multiplied by n. So the opposite of multiplying by 3 would be to divide by 3. So when I divide the left-hand side by 3, it's everything on the left-hand side being divided by 3. So I already have t subtract 5. I'm going to write that all as a fraction over 3. When I divide the right-hand side by 3, 3n divided by 3 leaves me with n, and this is what I was aiming for, n to be the subject. So n equals t subtract 5 all over 3. Question 16. The diagram shows a ship's journey from P to Q to R. So P to Q to R. So this is the journey the ship has taken. The diagram's not drawn to scale, so that tells us that we can't measure anything directly from it. The ship travels on a bearing of 100 degrees for 8 kilometres from P to Q. So from P to Q, 8 kilometres, and it's a bearing from north of 100 degrees, and that's marked on the diagram for us. It then travels on a bearing of 160 degrees for 8 kilometres from Q to R. So we're going from Q to R, 8 kilometres, measuring from north on 160 degree bearings. That's all labelled on the diagram for us. Part A, explain why the angle X is 100 degrees. So this angle here, guys, we're explaining why that angle X is 100 degrees. Okay, so what we need to recognise about bearings and those north lines, so these two north lines here, guys, point directly to north, they are parallel. So they are parallel lines. And what we have here, if we take this 8 kilometre distance, we have a transversal that's cut these two parallel lines. So we're going to use angles in parallel lines here. A couple of ways you can do this. The easiest way is knowing that this angle and this angle are equal. And they are equal because they are alternate angles. So we're going to simply write, we're explaining why angle X is 100. Well, the north lines are parallel lines. So I'm going to put alternate angles between parallel lines are equal. There we go. And then it says, part B, work out the bearing of R from P. Give a reason for each step of your answer, okay? So we're working at the bearing of R, but from P. So what we're aiming to get here is this whole angle here. So we're starting at P, from P, measure clockwise from north to the point R. So we're looking at this line, this dashed line that joins us. So we want this full angle here, guys. Okay. So there's a couple of different ways we can do this. So I'm going to start by working with angles on a straight line. Okay, so if we have this angle here of 160 and then this angle here, so angles on a straight line must add to 180. Okay, so the angle, the full angle here must be 180. So we've got 160, so this must be 20. We know this is 100 from part A. So I'm going to write angles on a straight line add to 180 degrees. Okay, that's my first reason, and I've been marking things on the diagram, which is absolutely fine. So we want the bearing of, so we're trying to find this angle here. So we've got this interior angle here of 120 degrees. Okay. Now we're going to work with the other two angles inside this triangle that's been formed here. So this angle and this angle. Okay. But what we need to note about this triangle that's been formed is it's an isosceles triangle, guys. So we've got 8 kilometers and 8 kilometers. So that tells us that the base angles in this isosceles triangle are equal. So we're going to write here base angles in isosceles triangles are equal. So these are the base angles because they're at the bottom of those equal sides. So this is 100 plus 20, so that's 120. So I know angles in a triangle add to 180. So that's 120. 180 subtract 120 is 60. These two are equal, so 60 divided by 2 is 30. So this is 30 degrees and this is 30 degrees, guys, okay? And I'm going to write my reason here. I used angles in a triangle then, didn't I? Angles in a triangle add to 180 degrees. So now I can work out the bearing of R from P, this full angle here. It's 100 plus 30. So bearing of R from P is 100 plus 30, which is 130 degrees. Now what's really important here, guys, is when you're giving bearings, they have to be free figures. So if that was less than 100 degrees, we'd have to put a 0 in the front, but it isn't. We've got 1, 2, 3 figures, so that works for us. Question 17a. Brad is a landscape gardener. One working day, he spends 3/7 of his time designing a garden, 5/14 of his time digging, and the rest of his time buying plants. What fraction of his working day does Brad spend buying plants? So this is one working day. So he spends 3/7 of that one day designing it, 5/14 of that one day digging it, and the rest of the time buying plants. So if we subtract these two fractions from 1, so 1 subtract 3/7, subtract 5/14, that is going to tell us what fraction of his working day he spends buying plants. So to be able to subtract these, I need them all to be over the same denominator. So we've got 7 and 14. Well, 14 is a multiple of 7, so I'm going to multiply this fraction by 2. So that makes it a fraction over 14. I'm going to write this as a fraction over 14, which would be 14 over 14. So we have 14, subtract 6, which is 8, subtract 5, which is 3. So it's 3/14 of his day buying plants. Part B. Arun is an architect. One working day, he spends 324 minutes of his time on paperwork. This is 3/5 of his working day. For how many hours does Arun work on this day? So 324 minutes is equal to 3/5 of his day. Okay, so I'm going to find out what 1/5 of his day would be. So 1/5 of his day would be dividing this by 3. Okay, so 324 divided by 3. 3's into 32 is 10, remainder 2. 3's into 24 is 8. So 1/5 of his day is 108 minutes. So I want to find out how many hours he works on that day. So I want 5/5. So I'm going to multiply that by 5. So 100 times by 5 is 500. 8 times by 5 is 40. So it's 540 minutes. We want hours, guys. So I'm going to do 540 divided by 60. Couple of different ways you can do this. But I'm just going to count up in 60. So 60, 120, 180, 240, 300, 360, 420, 480, 540. Counted up in 60s because there are 60 minutes in an hour. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 hours worked that day. Question 18a. 20 teenage boys take part in sprint races over 100 metres. So 20 teenage boys over 100 metres. One of the boys draws a graph to summarise their time. So we've got the 100 metre sprint time for boys. Here we've got the number of boys and we've got the time it takes them in seconds. Make one criticism of the diagrams. This is a 1-mark question. So one criticism of this diagram is that there are gaps between the bars because time is continuous, isn't it? It's a continuous measure. So the bars shouldn't have any gaps. So we're just going to put there are gaps between the bars. 18b. The bar chart shows the favourite holiday activity of a group of 30 students. So favourite activity, number of students, and then we've got beach sports, fun fair rides, water park and cycling. Use the bar chart to complete the pie chart opposite. So we've got a pie chart on this other page here. You may use the table to help you. You must show all your working out. So we are going to use that table to help us, guys. Okay, so we're doing this bar chart, but we need frequencies to start off with. Okay, so we want the frequency of beach sports. Well, beach sports goes all the way up to here. So that's 8, 10, so here must be 9. So we're going to put 9 for beach sports. Fun fair rides goes all the way up to 12. Water park up to 4. And then cycling up to 5. Now that we have our frequencies, we don't need this bar chart anymore, so we can just deal with our pie chart. So now we need to work out the angles that we're going to plot in this pie chart for each of these different activities. So we need to find out this total here. Now it did tell us at the start of the question that we were working with 30 students. So let's just check. 9 plus 12 is 21, plus 4 is 25, plus 5 is 30. So the total is 30. Now angles in a full circle is 360. So we're going to do 360 divided by 30. Well, let's do 36 divided by 3, shall we, to start off with. So 36 divided by 3 is 12. So each one of these people is worth 12 degrees. So we're going to times everything by 12. So 9 times 12, or 9 times 10 is 90. 9 times 2 is 18. 90 plus 18 is 108 degrees. 12 times 12 is 144. 4 times 12 is 48. And 5 times 12. 5 times 10 is 50. 5 times 2 is 10. 50 plus 10 is 60. And just do a quick check. We want these to add to 360 degrees. So 108 plus 144. So that's 252 plus 48. That's 300 plus 60 is 360. Fantastic. We've got the angles now that we're going to draw into our pie chart. So to draw the angles on our pie chart, we're going to need a protractor and we're going to need a pencil. I'm using a mechanical pencil here. I promise you it's a pencil. But a pencil is important because if you make a mistake, you want to be able to rub it out so that you can redo with the correct drawing over the top. So we're going to plot these angles onto this pie chart, and we've already got a line drawn here. That's the line that we're going to start from, guys. So the centre of our protractor here is going to go on that dot at the centre of the pie chart, and then this line here, the 0 line, is going to lay flush with that line that's already drawn for us to give us our starting point, like that. So the first sector that I'm going to draw is the beach sport, so it's 108 degrees. So 0 is here, so I'm using the outer ring. So I'm going to go round, so I've got 100, 105, 6, 7, 8. So I'm going to mark a point there, and then I'm going to line it up with the centre, and I'm going to draw my sector. What's really important here is now that we label them. You can write beach sports in full, but they've put B, so I'm just going to put B for beach sports there. Okay, I've got an angle there nice and clear, but you can put your angle on there as well if you want to. It's really good for marks with the examiners that they see you've worked out the correct angles, even if everything goes a little bit wrong here. Okay, the next section we're going to draw is the funfair rise. That's 144 degrees, but I now need to start from that line that I've just drawn. So I'm going to turn my paper round. I'm going to do exactly the same process. The centre of my protractor goes on the centre of the pie chart. This 0 line is going to lie flush with that line there. Good. We're doing 144 degrees for this sector, so we're going to go round 140, 1, 2, 3, 4, make a mark, and then join it up with the centre of the pie chart. So that was funfair rides, that sector there. So I'm going to label that with an F, and I'm going to put, oh, break my pencil, 144 degrees there, just to make it nice and clear. The next sector that I'm going to draw is the water park. So the water park is 48 degrees. And again, I need to start this sector from the line I've just drawn. So I'm going to turn my pie chart around again. Centre of the protractor with the centre of the pie chart. The 0 line of the protractor flush with that line that you've just drawn. So you pop on the centre, flush. And then remember, this one is 48 degrees. So 10, 20, 30, 40, 45, 6, 7, 8. So make a mark and then join the centre of the pie chart up with that mark. So that sector there is the water park, and that was 48 degrees. So there's one sector left, okay, and that has to be cycling. I don't need to plot it. If I've plotted these angles accurately, then that should have left me with a 60-degree angle there, and that's for cycling. What's really important with pie charts for full marks, guys, you label the sectors of the pie chart that you've drawn. Examiner can see them nice and clearly, but you've also clearly shown the angles that you've calculated as well. Question 19. In 2019, €1 is equal to 0.9 pounds and $1.25 is equal to £1. In 2019 again, here so the dates match, a silver pencil cost €110 in Germany. The same pencil cost $125 in the USA. In which country was the pencil cheaper? We're going to tick a box, but we've got to show all our working. So we're not actually going to tick a box, guys, until we've done some working out. So we have the pen, we have the cost in euros and the cost in dollars. We can't compare them directly at the minute because they're different currencies, different units. So we need them both to be the same unit. Now these conversion rates here take us from euros to pounds and from dollars to pounds. So we can convert euros to pounds and dollars to pounds. And once they're both in terms of pounds, we can compare the amount. So I'm going to give myself a little proportion table. If you've watched my other videos, you'll know that I enjoy using a proportion table. So we're going to start with the price in euros. So €1 and pounds. So €1 is equal to 0.90 pounds. Okay, we have 110 euros in Germany. So to get from 1 to 110, we would have scaled up. We would have multiplied by 110. So I need to do the same on this side. Now we're working on a non-calculator paper here, guys. So I'm going to do 0.9 times 110. So I'm going to times 0.9 by 10. So I'm doing 9 times 110. Well, 9 times 110, 9 times 100 is 900. 9 times the 10 is 90. So that's 990, okay? But I multiplied by 10. So now I need to divide by 10 because it's a multiplication. I need to reverse that. 990 divided by 10 is 99. So it would be £99 in Germany. So let's make a note that that's Germany. Okay, so now we're going to convert the USA's dollars into pounds. So we're going to use another proportion table. And we're going from dollars to pounds. So $1.25 is equal to £1. So we have $125. So to get from 1.25 to 125, we've scaled up and we would have multiplied by 100, because if you see 2 decimal places here, but we've got no decimal places here, so we would have multiplied by 100. So we need to do the same to the other side. So 1 multiplied by 100 is £100, and that is the USA. So now we're going to compare these prices, guys. In which country was it cheaper? Well, it's £99 in Germany, £100 in the USA. So Germany is cheaper by £1. So we're going to tick Germany for our answer.